complete blackness. That's what you would see looking directly at a black hole. It was long believed that no one could possibly see a black hole because we see via particles of light which cannot escape the massive gravitational pull of a black hole. But scientists weren't deterred by the odds and came up with an ingenious way of viewing and imaging them, and have now generated images of two supermonster black holes in our universe. The first image of a black hole. It was just 3 years ago that scientists were able to generate the first image of a black hole. The infamous glowing rings of light of this widely spread image are formed from the immense gravitational energy that bend the fabric of space and time, drawing streams of hot radiating matter towards the dark center of the black hole. In order to get this image, a team working with the Event Horizon Telescope started to collect an astonishing amount of data taken from more than 300 scientists stationed at 80 institutions working on 8 of the most powerful telescopes around the globe. All of the collected data amassed was over 5 petabytes of information. Keep in mind that a petabyte is equivalent to 1 million gigabytes. That's a mind-boggling amount of information to try to work with and understand. But their work didn't stop after generating the first image of a black hole. But the newest black hole to be captured has a very special place in our home galaxy. What black holes did they image? The 2 supermassive black holes that scientists took images of are M87 Star at the center of the M83 galaxy 15 million light-years away, and the supermassive black hole that sits in the center of our own Milky Way, Sagittarius A Star. The label of supermassive is reserved for black holes with masses millions or billions of times larger than the mass of the Sun. Until researchers were able to generate these images, these 2 black holes have always appeared relatively similar to astronomers, and many people assumed that they were 2 of a kind. But once they were able to study these new images, the team of scientists realized that these 2 black holes are extremely different, including their difficulty to image. This new revelation has shown scientists that black holes may be a more diverse group than they had ever considered. How are the images generated? The images of black holes are taken by detecting light from the material surrounding and swirling around the black hole, because the body of the black hole itself does not emit any light. In the center of the galaxy M87 sits the supermassive black hole known as M87 Star, weighing in around 6.5 billion solar masses, making it quite a bit larger than our own black hole. This black hole is rather quiet relative to others, and the material orbiting it is moving extremely slowly, taking multiple days to complete a single orbit. This slow motion was not overlooked by scientists and is one of the reasons they chose to image this black hole first, as its leisurely pace makes it much easier to photograph. Sagittarius A Star. Sagittarius A Star, on the other hand, was a bit more tricky to image. The Milky Way's black hole only weighs around 4.5 million solar masses, which is on the smaller size for supermassive black holes. And unlike the black hole at the center of M87, the material swirling around Sagittarius A Star is extremely close to its event horizon and completes an orbit every couple of minutes. The radiation coming from Sagittarius A Star changes so quickly that when the first images were generated, the team had trouble reaching a consensus as to what exactly they were looking at. Activity around these black holes. Another key feature that the researchers were able to notice is the difference in how these 2 monsters were feeding. While M87 Star has quite a turbulent region near its surface as it constantly consumes the material swirling around it, Sagittarius A Star is a much slower and more dainty eater. One researcher compared a human's diet to the amount of matter this black hole consumes, and it would be equivalent to if we only ate 1 grain of rice every million years. This means that while the material swirling around Sagittarius A Star is moving extremely quickly and appears to be a violent and active region, the black hole itself is feeding and growing extremely slowly. This makes the environment at the surface of the black hole to be quite calm and gentle relative to a black hole that's an active feeder. But relatively gentle is not saying much when you consider there will still be the extreme temperatures, massively powerful electromagnetic fields, and the amount of turbulent gas swirling above. What did they learn by imaging Sagittarius A Star? Sagittarius A Star was by far the most difficult black hole to image, but because the majority of black holes in our universe are in a similar state of slow feeding and growth, it can give us more insights into many black holes that fill the universe. By learning more about the black hole in the center of our own galaxy, scientists hope to understand what makes the most abundant type of black hole tick. You may have noticed that all of the images of black holes look similar to each other, with a dark, dense center surrounded by a bright ring of swirling matter. These features are the results of the same fundamental force, gravity, in one of its most extreme forms, giving all black holes a similar, menacing structure. What does this mean for the future? The image and information published in the Astrophysical Journal letters of Sagittarius A Star was actually the first piece of concrete physical evidence that finally proved the existence of the supermassive black hole sitting at the center of our own galaxy. Scientists hope that by studying these images and testing our current theories about the regions with the most extreme warping of space-time, they can begin to better understand how gravity functions and how it can be used for our benefit. This new information and data have also helped further a branch of research trying to understand and explain the role that supermassive black holes play in the formation of galaxies throughout the universe. Could these images help unlock the forces that control the birth and death of the billions of galaxies found in the observable universe? Thanks for joining us. Be sure to comment down below and let us know what object or objects in space that you want to see a picture of. If you liked this video, please hit that like button and be sure to subscribe so you don't miss any of our new content. See you next time on Matter.